Hello and welcome. In this video I'm going to complete a series of tasks about BGP on OcNOS devices. The task includes these. The first thing is I want to configure iBGP between router 12 and 14, which means that these two on AS400 down here. And I'm going to make sure the loopback interfaces are used for this connectivity. Then I'm going to configure R13, but I cannot configure MPLS, I cannot configure BGP, so this should be a normal core. Just OSPF is going to run on that as an IGP. And the last one says that I need to make sure that this R15 can reach this R6 up there. So this means that I have to be able to go through here and through here. What it means basically is AS400 is going to act as a transit service provider, something like that. And we just want to make sure that this transit is going to, send and receive the packets. We don't have any problem with prefixes, but packets are going to have a little challenge that we are going to discuss that, and we are going to fix it so that we can see what ways are there to just do it. And the problem is they have said that I cannot have something like an MPLS inside my network, which means that I cannot create a tunnel. So I have to really use this route as a router which is going to transit my traffic to the other side. So let's try this, and the first thing is I have just configured OSPF and IP addresses on all of these from 15 to 6, but what I'm going to do is to configure adjacent neighborships, BGP neighborships between router 6 and 12, 12 and 14, and 14 and 15. So let's first of all start with router 12. So router 12 is here. For now, if I say show IP interface brief, you can see the IP addresses which are assigned to these router. So if I just try to ping 10, 6, 12, 6, you can see that this is reachable. Okay, so let's go to configuration mode. First of all, I'm going to say router BGP 400, and I'm going to configure a BGP router ID, and that would be 12, 12, 12, 12. Then I'm going to configure the neighbor. One of them is going to be R14. So I would say 14, 14, 14, 14, which is in remote AS 400 with an update source of 12, 12, 12, 12. The other neighbor which I'm going to configure is going to be this one, 10, 6, 12, 6, which is in remote AS 100, and that would be this. And I need to go to address family IPv4 unicast, and I'm going to activate these neighbors. So the first one is going to be this one, so I'm going to activate it, and the second one is going to be this one, which I'm going to activate it. Okay, so now that I have activated these, let's just advertise network 12, 12, 12, 12 slash 32 into BGP table. And finally, I'm going to commit the configuration. Okay, so I need to see that I have adjacencies with router 6. Let's go back to router 6 here and log in. And then what I'm going to do is to say show run router BGP. And it says that I have already configured this, so this means that if I say show IP BGP summary, I should see that I have adjacencies with router 12. Great. And if I say show IP BGP, I should see 12, 12, 12, 12 in here after some time. For now, I'm not seeing it, but after some time, I should see. Let's just clear IP BGP any inbound. And then I'm going to show IPBGP one more time, and now you can see that 12 is reached here from AS400. So let's go to router 14 now. On router 14, I'm going to log in, and then I'm going to say en configure terminal router BGP 400, and BGP router ID is going to be 14, 14, 14, 14. Then I'm going to configure the adjacencies. So 12, 12, 12, 12 is going to be in the same remote AS as I am, and it is going to use update source of loopback. Let's say 14, 14, that would be better. Okay, the other neighbor which is there is going to be router 15. So that would be 10, 14, 15, 15, which is in remote AS 300, I guess. Let me just check. So it would be in 300, yes. So I'm going to configure this as remote AS 300. Now let's go to address family IPv4 unicast, and then I'm going to activate these neighbors. So that would be activated, and also this one would be activated just by this command. And let's advertise a network of 14, 14, 14, 14 slash 32. I'm going to commit this, and this is done. And let's just save everything. The same thing should happen on router 2. I'm going to save everything, 12 of course. And finally router 15 is going to be configured for us. In here I'm going to say configuration mode router BGP 300, and here we just made sure that this is 300, that's right. So BGP router ID is going to be 15, 15, 15, 15, and my neighbor for now of course is going to be 14, not 14 actually, 10, 14, 15, 14, which is in remote AS to 400. Okay, let's activate this. Address family IPv4 unicast, and this neighbor is going to be activated. And also let's advertise a network of 15, 15, 15, 15 slash 32, and commit the configuration and also save everything. Okay, now the overall configuration is done. We have adjacency between 15 and 14, between 14 and 12, and between 12 and 6, which means that if I go to router 6 I should see this prefix of router 15. So I'm just going to go back to router 6 and I'm going to check this one. And again I need to clear of course IPBGP in and then show IPBGP, and I guess I should have this command on router 12 and 14 as well. So I'm going to say do clear IPBGP any inbound and of course outbound, and I'm going to execute these on router 14 and router 15. And if I just go back to router 6 and one more time this one, I'm going to see 15 here. Great. So 15 comes from 300, and after that goes through 400 and gets to me. It is validated because I know about the next hop and I have no problem reaching there. And what I'm trying to do is to just try to ping it. Is the ping going through or not? If I just say source IP is going to be 6666, because I'm pretty sure that router 15 knows about this. Do show IP BGP and do show IP BGP of course knows about 6666. So the traffic should go through if I hit enter. However, there is a problem. What's the problem? The problem occurs in here. So what I have is router 6 sends that traffic to 12. 12 wants to send it to 14, and in between router 13 doesn't have any clue about what we are trying to do. Router 13 doesn't have any idea about these 15, 15, 15, 15 or 6666. So if I just go to router 13, router 13 is going to be a normal OSPF router inside our network. So I'm going to say OcNOS, and I'm going to say EN, I'm going to say show IP route. The only thing that it knows is its own autonomous system. So that is going to create a black hole. Now, there are multiple ways to fix this problem, but the thing is, we are asked not to enable something like an MPLS network. We cannot create a tunnel between 12 and 14. We cannot do anything other than advertising every BGP route that we receive into IGP, so that router 13 knows about that, and from there back to BGP here. So that is going to fix our problem, but that's going to put a huge load on R13, specifically if R13 is not a very strong router and doesn't have enough resources. That's going to cause problem for us. So what I'm trying to do is to do this. Let's go to router 12, although this is previously said that this is not a good idea, but I'm going to do that. I'm going to say router OSPF 1. I'm going to say redistribute BGP. This is 400, and after that redistribute BGP. Let's see. It says that redistribute BGP not 400, and hit enter. And then I'm going to say commit and do WR. Now if I just go to router 14 and do the same thing here, router OSPF 1, redistribute BGP, and hit enter, commit, and save the configuration so far. Now if I go back to router 13, let's see what we have here. Now router 13 knows everything about all the prefixes that are redistributed from BGP into here. So let's go to router 15 and now check this one more time. So far I know everything about 1, 2, 3, 4, 5, 6. I know everything about this. If I try to show IPBGP, I still know about this. Just because I want to make sure that everything is okay, I'm just going to clear everything, and then I'm going to check IPBGP again. Okay, great. Now if I just go to router 6, try the ping, this time ping goes through. Okay, that is a fix, and there is something that I'm going to speak about that, but I'm not going to configure it. Something that says, we call it BGP synchronization, and BGP synchronization rule basically says that I'm not going to advertise the routes that I have received from my IBGP neighbor to another autonomous system unless this is verified and validated by IGP. This means that it should be there in your IGP table. Otherwise, you're not going to use it. This rule is called synchronization, and by default synchronization should be off. Now let's do something. I'm going to go to router 14 in my diagram. This is here, and I'm going to see what has happened to router 6's network when it reaches to router 14. I want to see what I have in my routing table. So I'm going to say on router 14, I'm going to say show IP route, and here is 6666. You can see that it is not a BGP route, it is an OSPF external route that I have here. So I have it. This means that I can use it. Now the rule for synchronization says there should be validation, otherwise I'm not going to advertise it. For now I don't have any synchronization. By default, no synchronization is allowed, which means that without any verification, I'm just sending this to the other side. I have it here, so synchronization is going to affect this and see what the effect is going to be. I'm going to enable synchronization on R12 and R14. So I'm going to go to configuration mode, router BGP 400. Under address family IPv4 unicast, I'm going to say synchronization and hit enter, commit. And the same thing is going to be done on router 12. So I'm going to say configuration, router BGP 400, and router BGP, of course. And under address family IPv4 unicast, I'm going to say synchronization. So let's see the effect of this command right now. Now if I go to router 15 now, which is in AS300, and I'm going to say clear IP BGP any out and in. Of course, out was not important, but in is more important. But anyway, I'm going to say show IP BGP. Now you can see that I have 6666, which means that this has passed the synchronization rule on router 14, and now I have it here, and I can just try to reach it. So if I just say ping 6666, and I'm going to source it from something that the other side should know about, you can see that the ping goes through without any problem. So synchronization, is it useful or not? For now, it doesn't really matter in my network. You can see that without synchronization, I have no problem. But synchronization is going to add another layer of just check to whatever that I'm advertising to the other side. Should I use this kind of a configuration here, for example, on router 13? No, of course not. One of the reasons, because we don't want to, add some, in case I want to, advertise everything to IGP. IGP is not going to be able to handle a lot of routes. For now, you can see that we have no problem because I don't have more than a, couple dozens of routes in my network. But if it is something like hundreds of thousand routes on the internet, specifically with the scenario that I have, a transit service provider, so that is not going to handle this amount of routes. IGP is not going to be able to handle this amount of routes. So either you go with a tunnel from router 12 to 14, any type of tunnel, doesn't matter, or you add R13 to BGP, and that's going to fix the black hole problem that we just faced it. Now in next videos, of course, I'm going to configure MPLS on AS300, and that's going to be a solution for BGP core network. And our routers do not have to have so many routes in their routing table, but they are not going to cause any black hole in our network as well. So I hope this has been informative for you, and see you in next video.